All right. So now we're doing FreeCodeCamp Legacy Python for everybody, networking text processing. All right. Let's make sure we have our notes out right here. Let's scroll all the way to the bottom. Boom, like that. And let's go.
Okay, so now it's time to teach you a bit of complexity about text processing. Up till now, we've kind of been ignoring the complexity of text processing. Everything that I have been doing, most of what I've been doing is in ASCII, the Latin character set, the character set that, United States, Europe, lots of Western civilizations use this character set.
Western civilizations, what, like, anyway, whatever. He comes from the old days. Civilizations, come on now. American Standard Code for Information Interchange. I didn't know that's what that stood for. Let's go.
And if you go back to the 1950s and 1960s, we were happy to have one computer, and we didn't care what the character set was as long as what you typed on the keyboard came out on the printer.
True, I can imagine. Like imagine like it's like back in the old days, and we're like young men, right? Young men and women in the 60s, and also there was civil rights. Anyway, let's imagine. Anyway, so if there was like just like any kind of crap computer, you just be like, oh, that's it. That's where we're at. You just go over there and you just go start running on it. Because what else? What other choice do you have? Go run outside and start plowing the fields. Let's get on that computer. How about that? So yeah, this guy. You're looking at a really lucky guy here. To have been running computers back when computers were very rare. All right. So this is you're looking at a lucky guy. That's a lucky guy right there. That's what lucky guys look like. Let's go.
Didn't matter. And as the 70s and 80s came along, certainly 70s, we needed some interoperability. And so they standardized on a character set, but they standardized on a character set, certainly in the West, that did not represent anything. And so if you look at this, at this sheet, basically what it's telling you is for the various characters, there's some non-printing characters, white space, non-printing characters, and then here's some printing characters like the and key, the 0, and then the uppercase characters, and then the lowercase characters. And there's 128 of these possible values. And there are nothing even for Spanish or French in here. And it's also why, by the way, uppercase lower letters in Latin sort lower than lowercase letters, and we saw that in some of the string stuff. And what these do is it maps and says, okay, and a lowercase a maps to the integer number 90.
Before anybody jumps on anything like, hey, he's racist or whatever, number one, it was the 60s. It was in America. Number two, I see some Arabic numerals right here. So let's not say it's not inclusive. I don't see Roman numerals running around on this thing. And this guy's not Roman either. So let's understand. 7,
which in base 16 is 61, and in octal it's 141, but in binary it's 8-bit numbers, and so these are 8 bits, otherwise known as a byte, and they're very efficient. Like when you buy a disk drive, it's megabytes or gigabytes or whatever. That's how many of these kind of characters it can store. But unfortunately, this doesn't work for more complex characters. You can figure out these numbers inside of Python by using the ORD function. And so you say, what is the ordinal, or the numeric representation of the uppercase H, lowercase e, and new line is a character as well. And so, like 10 is the ordinal position of new line. And this actually has to do with sorting, so that lowercase e, is higher than uppercase H. And that's just because in the simplest of sorts, we just sort them numerically. So new line, if you go back to the previous little sheet, new line is this 10 right here. It's that 10, which is a line feed, and that's a 10. And that's why when we print new line out, we get a 10. And so again, in the early days when strings were simple, we just represented them as 1 byte per character. But the problem is that, as we have gotten more complex, and in today's modern world, it's simply unacceptable to say that the only thing computers can understand is ASCII.
True. All right, so that was this. That was the stopping place I was looking for, so we go write this stuff down. So let's write this stuff down. I think there's a lot of actually. No, there's not that much actually. Let's just write this down. We don't need to write the ASCII thing down because you could just, if you want to look up ASCII, you just type in ASCII chart and something will pop up on Google, or maybe even no, just on Google. I wouldn't do it with ChatGPT. All right, so let's do this. Let's make some notes out of this. Representing simple strings. Let's go. All right, so representing simple strings. So each character is represented by a number between 0 and 256. Stored in 8 bits of memory. Okay. So, the byte is the 8 bits and the bit is the bit. All right? And the bit is the 0 or the 1, right? Right. So, here we go. Let's go to the next one. We refer to 8 bits of memory as a what do we got? Anyway, as a byte. So BYTE. That's what the 512 bytes something the other day of memory. Okay. So much punctuation. i.e. my disk drive contains 3 terabytes. We don't need to capitalize that word. Terabytes. It's like capitalizing 2 cups of water. No, we don't need to do that. It's a measurement of memory. It's not a proper noun. Good. Now the space over the ORD function, the order function, I don't know, ORD function tells us the numeric value of a simple ASCII character. Cool. Okay, so yeah. Let's drop this down. Let's not do that. Let's drop this down here. Okay. And then let's also drop this down. Space it, go to the end, pull it back to right here. And then let's drop this down. All right. So now we've got some room to type this stuff. How many is this? 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 5, 6. That's fine. Let's start right here. All right. So we've got 3 chevrons. We're saying print. That's not how we say it. Print. Then we're going to do ORD. And we're going to have H, capital H in there. And what's going to come back from that little print statement is going to be 72. That's where H lives, turns out. Then we've got print. And then we've got ORD. And then we've got another string inside there with E in there. And then we're going to get 101. That's where that lives. According to ASCII. I don't know. Maybe there's different data sets that have, other characters in the front. Print. And then we're going to do ORD. That's not it. ORD. And then we're going to do /n. All right. And then we'll have 10 right here because that's where new line lives. Okay, like we saw in the video. So there's that. That's all the stuff. And he already discussed all this stuff. So we can just go forward back to where we were. So let's just press this. Let's press the whatever arrow, right arrow key a bunch of times until we get to this one. Let's do it here. Two back from here. Two back from here. Two to the left from here. Let's go.
World, it's simply unacceptable to say that the only thing computers can understand
That's where we were.
is ASCII.
True.
And so this leads to a very, very, from the simplest of character sets to a super complex character set called Unicode, which basically is billions of characters, potential billions of characters for every language and every character set.
So inclusive.
So space
That's
in
good.
Unicode, it's easy to take very small variations of characters and give them a space. It's so large that you can have you can have pretty much any character that you want. So that's Unicode. The problem is that if we send
look some more. Yeah, that's interesting. And then somewhere in there, you can also have emojis. And that's where they throw emojis also. I'm pretty sure you can submit your own emojis to Unicode, and it's cool. I don't know. I don't know how we should program some emojis because, you know, that's the kind of channel we have. Not today, though.
That you want. So that's Unicode. The problem is that...
Okay, before you get into the problem, our problem is that we need to write this down. So let's solve the problem by writing it down. Multi-byte characters. Here we go. Like this. Multi-byte characters. Multi-byte characters. That's interesting. Isn't that what Unicode does? UTF? Yeah, that's what I thought. To represent the wide range of characters computers must handle. Let's drop this down right here. We represent characters with more than one byte. All right, let's drop that down right after the in. How about that? Looks good. Sounds good too. Let's do this. UTF 16. We're not gonna have a space now. Fixed length 2 bytes. Yeah, okay. UTF-32. I didn't know we had one of those, but I guess it makes sense. UTF-32. We're going to have to move to that at some point. Or maybe we already have. I'm just behind. UTF. And it can be lowercase too, so we're going to do that. UTF-32. And that's going to be fixed length 4 bytes. We could have copy paste. Fixed length 4 bytes. Okay. You know what? We're going to drop all this down. This is... Yes, this is what we're going to do. All right. There we go. Because that's how I usually type it. Right, like that. I don't give any extra respect to anything in this thing if I don't have to. You know what I'm saying? We've got UTF-8. UTF-8. And then 1 through 4 bytes. 1 through 4 bytes. What? Fixed length 4 bytes. Fixed length 2 bytes. UTF-8 does 1 through 4 bytes. Turns out. Okay. let's come down here. We've also got this too. This is part of the UTF-8. We've got upwards compatible with ASCII. Okay. 4 spaces over. We're going to say automatic detection between ASCII and UTF-8. 4 more over. Then we're going to go UTF-8 is recommended practice for encoding data. Where's the cutoff? Right there. That's good. 1, 2, 3, 4, 5, 6. Okay. Is that a whole tab though? Nope. 1, 2, 3, 4, 5, 6. There we go. Whatever. All right. So here we go. We've also got what? Oh yeah. Data to be exchanged between systems. What does that mean? All right. Let's read this over again because I kind of forgot what was going on while typing. So, to represent the wide range of characters computers must handle, true. Wide range of characters. Oh, yes, true. We represent characters with more than 1 byte. Yes. Okay, so UTF-16 is going to be 2 bytes long. So that's even like the first one would be at 0, 0, a bunch of like 4 bytes worth of zeros. And a byte's 8 characters. So it would be 8 zeros 16 times here, and then 32, probably 8 zeros 2 times, which would be 16. Yeah, that's how that works. And then 8 zeros 4 times, which would be 32 zeros for the first character. And then this one is just, the first character is 4 zeros, and then you just add the next byte depending on where you are in the list, right? That's what this seems to be. Upward compatible with ASCII. I don't know what upwards compatible means. We'll hear him talk about it. Automatic detection between ASCII and UTF-8. Okay, something's going on that's automatically detecting. He'll talk about that probably. I doubt he'll talk about that actually. UTF-8 is recommended practice for encoding data to be exchanged between systems. Yes, so use UTF-8. Not a big deal in my opinion. Let's go. Let's go.
If we sent Unicode across the network, it would be way too large. It'd be this UTF-32, which instead of being 8 bytes per character would be 4 bytes per character. And so it would take all of the data that we build and make it 4 times larger. And it'd be very difficult. And so what they've come up with is ways to compress this. And UTF-16 is this weird thing. UTF-32 is really sort of the full Unicode pretty much. UTF-16 is a subset of Unicode. It's used in some countries. But the best practice for moving data across the internet or in a file that you're going to move between computers is what's called UTF-8. And so what happens is that UTF-32 is fixed length. ASCII is one byte. UTF-16 is 2 bytes. UTF-32 is 4 bytes. And UTF-8 has dynamic length, meaning that it is 1 to 4 bytes. And if it's only 1 byte long, it's perfectly compatible with ASCII, meaning that an ASCII file is also a UTF-8. And so here's this little sheet. It's not critical that you understand this graph too much, but basically as time passed, 2000 internet's coming, now 2014, pretty much overwhelmingly the documents on the internet that you might retrieve are UTF-8. Now, so UTF-8 is the recommended practice, and it's sort of a compression of UTF-8 can represent all the things UTF-32 can represent. It's just a compression of it so that, and with an overlap of ASCII, which is awesome. It's what you want. I don't even talk anymore. So
all right. So we got 2 strings here. Let's type this down before he Gets into it. All right, 2 kinds of strings in Python. We didn't have to have it in Korean, bro. It would have been a little bit easier. Not everybody's Korean. But everybody knows English, all right? It's just a cold, hard fact. Everybody that's trying to learn coding knows English. All right, so let's do that. 2 kinds of strings in Python. All right. So we're going to have it's going to be the example style. What's the difference though? Okay. Oh yeah, remember this? I think we already typed this down somewhere. I think we already typed this. Yeah, we already typed this down. We already know this. This is already in the notes, but I think way a long time ago. Let's get rid of this. We already wrote this down.
Python, we have always had sort of 2 ways of representing strings. In Python 2, the normal string was a byte string, was an ASCII string, was a Latin string. And if you wanted to represent Unicode, there was a separate kind of object that we had. And so you
I remember.
Do that. And
he does that because Korean is outside of the ASCII. Makes perfect sense now. Okay, my bad.
In Python 3.0 or later, one of the main features of Python 3 was to make Unicode and string the same. So that means inside of Python, when you have a string variable, it's a Unicode. Whereas inside of Python 2, it was a byte variable. And so now we have this notion separately in Python 2 and on Python 3 where we have byte variables. And so byte variables are, in effect, an array of bytes. So if there's ABC, that means it's 3 bytes. It's 3 bytes long. Whereas a string might be a 3-character string might be anywhere from 3 to 12 bytes long. So Python 2 had bytes and strings that were the same. Bytes and strings are the same, and Unicode is weird. And in Python 3, strings and Unicode are the same, and bytes are weird. Okay. And so that's what we've got to.
So as a typical trade-off, so let's type this down because we did not type this down. All right. Where are we? Notes. Let's do this. Python 2 v Python 3. Let's do it. All right. Python 2 versus Python 3. Okay. So let's see. Python 2. Python 2 did stuff like this. All right, we have x equals b, ABC. All right, and I guess that's a byte representation. Yeah, let's just do it like this. Okay, and then we've got type x. Type x. Oh, it gives us the type. Oh, yeah. All right, and then when we get inside of these, we get type is a string. Okay. Not that we've ever used that, but maybe one day we will, because it's good to know a lot of stuff. All right, so let's do this. We've got x equals Korean characters. Korean characters. Okay. And when we say type of what type X is, it's going to be type string. Okay. Type string. Okay. And then we've got X equals U. I guess that's how you do Unicode back in, I don't know, Python 2 days. And then we've got Korean characters. Korean characters. Okay. We would say when we do type X, we're going to get type is going to be Unicode. So this is different. Okay, so this is the odd man out in Python 2, but in Python 3 the bytes are the odd man out because I guess somebody figured out that people use Unicode more than they use bytes. That's probably what. And then if the trend ever goes back the other way, they'll switch it around again. Why not? So X equals this exact same thing. Okay. What, exact same thing? It's not the exact same thing, but okay. Let's try this. There's that one, and then this one. And then this will say type bytes instead of strings. So let's take this, drop it, but it's going to be type is bytes. Oh, big difference. Bytes like that. And then we've got this. Oops. This, it's going to be string again. Right? Yeah, it's going to be string again. So we'll get this. Oops. And do that. And then we'll do this. And that. And then we'll do, whoops, not that. Not that either. We'll do this. And we'll do this. And we'll take this. Do this, and the type's going to be string. That's what the difference is. String here instead of Unicode. So now we know that. And if anything comes up to where we need to know that thing, we wrote it down, so we will have that available in our brains. Let's listen to him talk about it.
To deal with. And there'll be times when we get bytes from APIs. When we call things, we have to then figure out what kind of thing those bytes contain, because the bytes might contain ASCII, they might contain UTF-8, they might contain various things. And so internally all the...
Okay. Oh my goodness. I don't know why I'm out of juice right now, but I guess it's because I haven't drank my your sponsor here brand coffee. No, I'm kidding. I'm not kidding. I mean, if I could get a sponsorship, I'll take it for sure. Trust me. Trust me. Trust me. But yeah. That was gross. If they were doing anything questionable, I would part ways in a heartbeat. Because that's the kind of guy I am. Python and Unicode. Python 3 and Unicode. Python 3 and Unicode. Does it need to be next to each other? I'm going to say no. Because in the next sentence, it's not like that. In Python 3, all strings internally are Unicode. Okay. Pardon me. So working with string variables in Python programs. Let's drop this down. Move it over. There we go. And reading data from files usually just works. That's one way of looking at things. I don't know if I could. When we talk to a network resource using sockets or talk to a database. Let's drop this down. Actually, we should move this over. Actually, you know what? Instead of that, let's do this. Not that. All right. All right. Okay. Good enough. Still not good enough though. Well, whatever. We're going to drop it down this short way, and then we'll do a longer way on the next ones. Okay. Talk to a database. When we talk to a network resource using sockets or talk to a database, we have to encode and decode data. We have to encode and decode. Drop it down here. Encode and decode data. Where are we? Oh, right. Usually to UTF-8. Usually to UTF-8. There we go. And then this is the same thing we had up here, so we're not going to retype that. All right, let's go.
The strings in Python 3 are Unicode. Most of the time, if you're inside the program or reading and writing files, we just work, and that's why we haven't mentioned it. But now that we're talking over sockets, and we're talking to the sort of random world out there, we have to be a little more aware of the data we're dealing with. Now, the good news is 98% of the time, or 95% of the time, it's UTF-8, which might also include ASCII, and so it's quite nice. But we have to be aware of this. And so if we are going to take...
Whew. Let's type it down. We're back at it, right? It's another week. Keep working. Keep working, right? All right, so let's go. Python strings to bytes. Python strings to bytes. Okay. When we talk to an external resource like a network socket, we send bytes. Like a network socket, we send bytes. Okay, we send bytes. How about that? Yeah, we're going to make this one a longer one. So we need to encode Python 3 strings into a given character encoding. Okay. When we read data from an external resource, we must decode it based on the character set so it is properly represented in Python 3 as a string. Okay. And for this one, we would do something like this. Whoa, what happened to bytes? Took a bite out of bytes. Took a chomp out of bytes. All right, so let's come over here. We could do something like this. While true. While capital true. It's Python, of course. We got to do it like that. While capital true. All right, let's try again. What we're going to do is say data equals my socket. Socket.receive 512 bytes, 512 bytes, so 512 times 8 bits. We're going to do an if statement inside of here. If, all right, if the length of data is less than 1, whoa, what are we going to do? We're going to break because there's no more data. All right. And then after that, we're going to say my string equals data dot decode. All right. And then we're going to also do print my string. My string. Okay. Let's look at this before we hear about it so that we can practice trying to understand things without getting told them, even though clearly I'm telling you. You can push pause yourself if you feel like it. This is just an example of what I'm doing to learn. All right, so while true, data equals mysocket dot receive 512. So we're going to be receiving 512 from the mysocket that we made earlier, that we're assuming we made earlier. If the length of the data is less than 1, we're going to break out of it, of course. My string equals data dot decode. So all this data is going to be the 512 bytes of data is going to be decoded and then printed out like this. So we're going to get the 512 and then the next line 512 and then on the next line 512 worth of bytes, right? And the next one 512 worth of bytes. And that's that. That's how we get that internet stuff. All right, we did this in the last video, so let's listen to him talk about it. Okay, let's go.
Data that comes off of the network in the byte. So if we are going to take data that comes off of the network in the bytes, then we have to make sure that we interpret it or decode it and in the right way so that internally the strings, which are Unicode, are properly represented. And so that's why when we read data in from a network connection like a socket, we have to say, hey, decode it. Now there's a couple things going on at that moment of decode. And so this is where we're doing it. We have to manage this in this code.
We already typed this down, so we're not going to type this out. But let's look at this before we listen to him talk about it. So an HTTP request in Python, right? We've got the import socket, so we're doing the socket thing. We've got mysocket equals socket dot this stuff that's necessary. I forgot what this stuff does, but we could go through. We could ask ChatGPT, honestly. mysock.connect, and then this is to the website that we're connecting to at its port. It's 80. I don't think we actually need the 80 in there because it's assumed, but maybe we do. I don't remember. Anyway, so we got command, and then we've got this get, and then we're getting this page on HTTP. We're using HTTP Hypertext Transfer Protocol 1.0, and then we're doing 2 line breaks. One because it's assuming one thing, and then another for another. We went over this in a video. I forgot what all of it was though. And then we're encoding it. All right, so we don't have to do the encode afterwards. So we say mysocket.send command. Okay, so we're sending this, and it's going to say yay or nay on if they're going to give it back, right? And then when they do decide to give it back, we're going to say data equals mysock.receive. So it's going to be this socket that we made dot receive. Okay, and then we're going to receive 512 bytes per gas pump, I guess. You think about it like I guess I would think about it. I mean, it's not the same thing, but think about like cylinders firing off in the car, like each revolution, right? Each time you shoot the gas in, and the spark plug blows it up, and it goes around, and then it goes around and around and around. Right. So it's gonna be 512 per cycle, right? It's a cycle. Anyway, And then if there's no more data, we break off, we print out, we're going to print out data.decode. Okay. We're going to decode the data that came around. And then we're going to close the socket after all that's said and done. Okay. Like it. Let's go. Let's see what he says.
Where before we send this stuff, we're going to encode it, which takes a Unicode string and turns it into UTF-8 bytes. There's actually a parameter here that you could do it different than UTF-8, but no one ever does. You might have to for certain situations, but so that says that we're going to encode this into UTF-8 before we send it, and then when we get something back,
we should type that down just in case we're in that sticky situation one day where it's either we remember there's an optional. Where's encode? Oh. Did we type this crap down? Oh, we typed this a long time ago, as in yesterday or Friday. That was a long time ago. Where were we? Right here. HTTP request. Encode. Let's put in here. Optional argument. For something
before we print this into, you might have to actually parameter a Unicode string and turns it into UTF-8 bytes. There's actually a parameter here that you could do it different.
Okay, let's go look at that. Encode method Python. Boom. There we go. All right. Parameters. Encoding. Optional. A string specifying the default is UTF-8. A string specifying the error method. Legal values are these. Are there illegal values? I guess everything that doesn't work. Everything else. CW3 schools. Let's just put CW3 schools. CW3 schools. Come on now. CW3 schools. Okay? Because look, if we're in a situation to where Google doesn't work and we need to do something for the internet, you know, it's time to go home for the day and just say, see ya. You know, this is a problem that you didn't that you're not paying me for. I don't have that much loyalty to the brand. You know, I mean, because you look, guys, you're employees. When you're an employee, don't give these people your life. Don't do that. You don't want to look. You're not their property. They don't have actual reason. They don't have that reason to take care of you. They have your people taking money from them. Okay, they have a reason to shortchange you every single time, and that's just life. Okay, that's life. Everybody, when you're going out to go negotiate, you're always trying to get the best deal for you. When you're an employee, you're getting paid not only in your measly salary, you're also getting paid in experience. Okay, so that's what the employer's betting on. Also, he's betting on the fact that you're an employee and you didn't put any. You're not really risking anything other than your time to write an application. You know, that's another true fact about the employee-employer relationship. You got to remember that. So, where were we? Oh, yeah, let's watch.
Than UTF-8, but no one ever does. You might have to for certain situations, but so that says that we're going to encode this into UTF-8 before we send it, and then when we get something back, before we print it, we're going to decode it. And that's how this ends up working out. And if you look at the documentation, you will see that sometimes it says it's a string or it's bytes. And so you take a byte array and you decode it to get a string, and you take a string and encode it to get a byte array. And so that's what we're doing. So you can think of the process as this way, and that is the network has these UTF-8, mostly UTF-8 resources, not ASCII. If it's ASCII, it's okay. So you read with the receive. So this receive here pulls data, or well, we have a Unicode string. Let's start with the send. So up here, We have a Unicode string. That's a Unicode string, even though there's no special characters in it, no Asian characters or French characters. That's a Unicode string. And before we can send it, we have to send it in UTF-8. If that had Asian characters, it'd be okay, and that would be set up just right so that the UTF-8 would be right. So we encode it first, and that's this CMD. This is now bytes. Okay, CMD is bytes, and then we actually send the bytes, and that goes across the network. We get back our thing, and we receive into data. Well, data is bytes, not string. It's bytes. We can say how big it is. Function's kind of like a string, and it has len, except that it is 1 byte per character, which means some of it might be UTF-8. And then all we have to do is say decode. Again, you could, if you were dealing with a situation where you weren't expecting it to typically be UTF-8 or ASCII, you could tell it UTF-16 or something, and it's more complex. But the simple thing is you just say, I'm going to clean up my data on the way in, I'm going to clean it up by running it through decode, and I'm going to encode stuff on the way out. And so sockets are the place where this comes into play. And so you'll see we'll always do this encode and decode every time we're sending data kind of outside of Python and inside of Python. So now that we've talked a little bit about character sets, we're going to make this even easier so you don't have to use sockets. URL lib is a bit of Python code in the library that does all the socket stuff for you.
Something to do it for us. I'm into it. All right. Question, which type of encoding do most websites use UTF-8? Don't forget it. Aha! And submit it. All right. I said all right. All right. So there we are using it. Now we're on to networking using your lib URL library in Python. Right? What did URL mean? I forgot. Anyway. And we'll see you next time.